Okay, so Unit 2, Day 2, we introduced functions and relations on Day 1, and now we're going to move on to doing some operations with them. So our learning target is I can add, subtract, multiply, and divide functions that are given in function notation. Okay, so by function notation, we mean like right here, this is function notation, like this. Instead of having a y equals, we have f of x and g of x. And the only difference between f of x and g of x is that they're describing them. It's like their name. Like this is function f, this is function g. They're two different functions. We had to give them different names to tell them apart. Now, some directions here. So we would say notation for these operations. If I wanted you to add two together, two functions together, I would write this. I'd put f plus g. Both of them are with respect to x, which just means they're written with x's in them. So that would mean I want you to add them together, and you probably guessed it. If I wanted you to subtract them, I'd put a minus between them. If you wanted to multiply them, a lot of times it's confusing to put a dot between them because there's another symbol we're going to talk about in Day 3 that looks a lot like it. It's a very tiny open circle, so a lot of times I just don't put anything between them. So fg just means f times g. And then f divided by g of x means divide them. Okay, so we're going to take functions and do the same usual operations you're used to seeing. So this here says take these two operations, add them together, which all that means is I'm going to take function f, which is 5x minus 6, plus g, which is x plus 3, and then look for like terms. And since I'm adding, just add up like terms. So 5x plus x is 6x, and then negative 6 plus 3 would be negative 3. This guy says subtract them, which with subtraction, you got to be a little bit more careful. So I got 5x minus 6 minus, and when it says minus x plus 3, I'm not just subtracting the x or just the 3. I'm actually subtracting both of them. So it might be easier to put minus x minus 3 instead. So now it's going to be 5x minus x, which is 4x, negative 6 minus 3, which is negative 9. So make sure you distribute the negative out. That's kind of what we're doing there, like distributing a negative 1 out. The next guy, g minus f. We know order matters when you're subtracting. Well, now we're going to have x minus 3 minus 5x minus 6. If I'm subtracting both of these, I'm subtracting 5x. I'm subtracting a negative 6, which is actually plus 6. So when I do my like terms, x minus 5x would be negative 4x. Negative 3 plus 6 would be a positive 3. Okay? I just saw I wrote this down wrong. This is a plus, and I put a minus, so that would be a plus. That means this is actually a 9. I just noticed that I copied that wrong. So be careful when you're copying. The next one is multiply. So I'm going to take function f, 5x minus 6, times g, which is x plus 3. And if we remember, when you're multiplying binomials like this, since these are both binomials, I'm going to FOIL. So first, outer, inner, last. So first, outer, inner, last. So first represents the first. I'm going to do the product of both the first terms. That's these two guys. So I'm going to take 5x times x. That'd be 5x squared. And then the outer terms is the first and the last. So it's going to be these two guys. So I'm going to take 5x times 3, which would be 15x. It's a positive, so I'm going to put a plus 15x. The inner then are these guys. The inside 2, negative 6 times x. It's a negative 6x, so I'm going to put minus 6x. And then the last would be negative 6 times 3, which is a negative 18. Anytime you FOIL, we're going to look for, is there like terms? I do have x's in the middle, so I've got 5x squared, and this would be plus 9x minus 18. Now the division, it's actually a little bit easier than it looks because you're actually not really dividing. All we're going to do is write one on top of the other. So f goes on top, 5x minus 6, and then x plus 3 goes on bottom. If you remember factoring, like is there something both these terms are divisible by? This time the answer is no. Same thing on bottom. There's nothing that x and 3 are divisible by. So since the answer is no, there's nothing to simplify, there's nothing to cancel, then that's just my answer. We don't want to accidentally cancel the 6 and the 3. Some people think, well, 6 and 3 are both divisible by 3, so that'd be a 2 and a 1. You can't cancel like that, and we'll get more into that later. But for right now, that is all you can do, so that's your answer. I didn't really do an operation, I just have the answer. And then I'm going to put g on top, so x plus 3 over 5x minus 6. Same idea, nothing can be factored out, so nothing can cancel, and that's it. So the backside now is going to be the one step further is now, you see there's a number here. So this means I want to add them together, then plug in 1, or you could actually plug in 1 first and then add them together. Both ways you do it, you get the same answer. I think some students would much rather, it's actually probably a little bit less work to plug it in and then add them together. So in this situation, I would do like f of 1 first. So this would be 2 times 1 squared plus 4 times 1 minus 6. And then do g of 1. So 2 times 1 minus 2. And then when you get those, add those together. So if I want to add them together, then I just need to add these two numbers together. So this first one here, if I plugged in 1, that'd be 1 squared is 1, times 2 is 2, 2 plus 4 is 6, so that'd be a 0. And then here I've got a 0, so 0 plus 0 is 0. Okay. Again, you could add these two together, like on the back side here, on the front side. We could have added them together and then plugged a number in. So like if this said 1, I could plug a 1 in right here, and I'd get my answer. So it doesn't really matter. I think a lot of times it's faster to plug the number in, evaluate, and then add. Totally up to you. So like for instance here, let me do it the other way. So this I'm going to subtract first, then plug in 3. So I'm going to have 2x squared plus 4x minus 6 minus 2x minus 2. That means I'm subtracting 2x, and then I'm subtracting a negative 2, which is actually plus 2. Combining like terms, I get 2x squared plus 2x minus 4. Okay, combining those together, and then that, so that would be f minus g of x. Now f minus g of 0 means plug 0 into that. So 0 squared, that'd be a 0, 0, that'd be a negative 4. Okay. Again, you could have plugged the 0 into both of these. In fact, f of 0, if I plug in 0 up here, that'd be negative 6, because 0 wipes all those out. And then on this one, if I plug a 0, that wipes that out. So g of 0 would be, negative 2. So if I took negative 6 minus negative 2, that'd be like plus, I get negative 4 also. So it's totally up to you which route you want to take on that. I'm going to speed things up a little bit. I'm going to start writing. I'm just going to pause my video so you'll see work just start showing up line by line here. So I plugged in 0 to both functions. So I got, when I plugged in 0 here, which it'll be about the same, should be almost exactly the same up here. Did I do it already? So here I've got g of 0 is negative 2. And then I plug in 0, I get negative 6. And if I subtract those, negative 2 minus negative 6 would be negative 2 plus 6, which is 4. On this one, I plugged negative 1 into f, and I plugged it into g. I evaluated them, got negative 8 and negative 4, and my operation was to multiply. So if I multiply these together, I'd get 32. Okay, on number 5, I plugged 3 into both of them. This evaluates to 24, this is 4. The operation between them was divide, so that would be 6. Okay, and I think I'm going to save some time. I'm going to skip number 6, same idea, plug it in, simplify. Down here, in fact, this is probably just more of the same thing. If you want to try it on your own, see this one is 6, 8, 5. These are the answers when you're done. Over on this side, negative 2x, because this is, you're not plugging a number in here, so negative 2x squared plus 6x minus 8. This would be 12x cubed minus 22x squared minus 18x plus 33. 2x squared minus 3 over 6x minus 11. So, sorry, I got off the screen there. So if you want to try those out on your own, I think you maybe kind of get the idea. If you don't really quite understand it, try these out. Raise your hand, ask me questions. I can work some of them with you.